Hi, hello there. So very quickly, so we're going to have a look today at the sine rule, which we've done in the previous video. But before that, we're going to have a look at a nice little, a cute little thing you can do with triangles. So here we have a triangle. Let's do the usual. A, there's A, B, there's B, and C, and there's C. So that gives you the angle of B, angle of A, the angle of capital C. Okay, so the area of a triangle, as we know, is half the base by the height. Okay, and in this case, if we were to translate this, it'd be, first of all, we'd have to put in a height. So, but because this is a acute triangle, we can just put in a perpendicular line from the highest apex to the baseline, call that H. So in this case, it'd be half of A by H. Okay, A being the line side opposite angle A, as we've been talking about in terms of sine, cos, and tan. So what happens if you don't have perpendicular height and you can't find it for whatever reason? So let's have a look at another way of doing it. So let's see, can we put H into some sort of formula? So now that we have a right angle triangle, then it would be true to say that the sine of B is equal to opposite over hypotenuse. So is there another way of rearranging H? Yes, there is. H is equal to C by the sine of B. So if I substitute that in there, that becomes half of A times C times the sine of B. Now, if we look at where this is, and I'll use some lines to do it, what you're really saying is, if you multiply this line by this line by the sine of the angle in between them and half the answer, you've got the area. So it's a way of getting the area of a triangle without knowing the perpendicular height. You just need any two sides and the sine of the angle between them. So it's just a cute little thing. I'll do a couple of questions on it in a while, but it's just a cute little kind of thing that you can use it for. So today, let's what we're going to do is we're just going to play around with some very basic sine rule and area rules, just for the fun of it, just to kind of get our heads into the crowd. So I'm going to abandon the old, I'm just going to free draw triangles because life's too short. Okay, happy days. So let's start with, let's do some 30 degrees, 50 degrees. And let's say this is 6 centimeters and that's X centimeters. So how would I find X centimeters? Well, let's check. First of all, it's not a right angle triangle, so I can't use Pythagoras. Okay. Do I have 3 pieces of information? 1, 2, 3. I do. Okay, let's check. Can we use the sine rule? Okay. So if I could use the sine rule, I can use the opposites. So I need 6 over the sine of 50. Okay. I'll use a darker pen here if you don't mind. 6 over the sine of 50 is going to be x over the sine of 30 degrees. Get out your calculator, make sure it's on degrees. And listen, there's always a quick algorithm for these things. So if it's the side that's missing, it's just going to be side angle divided by angle. So it's always, so if x is missing, it's just going to be 6 sine 30 degrees divided by sine 50 degrees. Just cross multiplying and doing your kind of magic, but it helps. So just do it all as one side. I'll try and give the answer to the nearest integer just to make things easy. 6 sine 30 divided by sine 50. sorry. 6 divided by sine 30 divided by the sine 50. 3.91. Let's call it 4 and we won't argue. Okay, to the nearest integer. We're not going to argue about this, okay? So there's a very simple one just to kind of get your head around the idea of it, I suppose, for want of a better word. Okay, we'll kick it up a notch and we'll try some tougher ones, I suppose. Let's think about it. So draw another triangle. Let's make the angle that's missing. A, 8 centimeters. 45 degrees, 10 centimeters. Find the angle A. Okay, so again, do your check. Is it a right angle triangle? Don't think so. Okay, and there's no indication that it is, so I can't use Pythagoras. So now let's check the sine rule, see can I use them. Do I have 3 pieces of information? Yes. Let's put them into the sine rule formula and see will it work. 8 over the sine of A is equal to 10 over the sine of 45. So in this case, we have an angle missing, so it's just going to be side times angle divided by side. Okay, so it's going to be 8 sine 45 divided by 10 is going to be the sine of A. But we don't want the sine of A, we want A. So A is equal to the sine inverse of all this. So let's do it. Sine inverse fraction 8 divided by the sine of 45 over 10. And we'll give it to the nearest degree just to stop any arguments. To the nearest degree, it is 34 degrees. Now, listen, they'll tell you whether it's the nearest degree or nearest whatever, but just do what they tell you, okay? So we'll try another one. Let's go a bit crazy on some of this. Okay. Oh, here we go. So we have a triangle with 2 sides and a missing angle between them, hint, hint, and they give you the area. Okay, Pythagoras is no good here. Sine rule is no good because I only have 2 pieces of information. I need 3. Okay, that's an external piece of information. It's not part of the triangle. Okay, so the only thing I can go with is I know that it's half any 2 sides by the sine of the angle in between them. So that means it's half 13 by 18 by the sine of A equals 78. Now, let's work it out. I'm just going to divide everything into, that's a product, divide it into there, and then inverse it. So A is going to be the sine inverse of 78 divided by a half of 13 by 18. Do it all in one go. That's what the calculator is for. Shift sine inverse fraction 78 over. This is the one time where I'd say go for the calculator because it's just going to make your life a lot. Nearest whole number, 42 degrees. Okay, so these are nice and cool. Okay, they're nice to play with. Okay, and obviously we're just doing all the simple ones. It's going to get a lot more kind of crazy, as the man says, but for the moment we'll just practice with the simple ones. So let's do a few more. Okay, these times we do a 3-to-1 pause job on it, and I'm not going to tell you anything, you just try and do them. I'm going to draw 4 triangles, and you have to find the missing letter. It could be a side, could be an angle. Okay, do another one. We'll just do 3 for now pages. Okay, so I'm going to do a 3, 2, 1. You're going to pause. You're going to give it your best shot to find those missing ones, and then we'll come back to it. 3, 2, 1, pause. Now we're back. Hope you got on. So first of all, I'm just going to do out the fractions. So this one's going to be 6 over sine of A is equal to 4 over sine of 50. Okay, this one is going to be x over sine of 30, 12 over sine of 80. And this one is going to be 16 over sine of 100 is equal to 10 over sine of A. Now, you know, the reality is this one we're going to have to do a sine inverse. This one's a straight answer. This one's a sine inverse. Okay, so this one we'll do it a different color so that we don't get kind of confused with this. This is going to be the sine inverse of 6 sine 50 over 4. Okay, don't know if that's coming up on the page at all. This one is going to be 12 sine 30 over sine 80. And this one is going to be 10 sine 100 over 16, and that's a sine inverse. Okay, so let's do them out very quickly. So sine inverse fraction 6 times the sine of 50 over 4. I don't know why it keeps doing that. Maybe I need to close off brackets or something. I don't know. Maybe it's this bit. Right. What is going on here? I give up. Okay. Let's do it again. Sine inverse. Sine inverse fraction. 6 sine 50. Maybe it's the multiplication thing. Over 4. All right. Why that's happening. Right. Let's do it in stages then. 6 by sine of 50 divided by 4 sine inverse. Okay, getting a problem there. Let's just check 4 the sine of 50, 6 over the sine of A. It could just be the fact that some of these just don't work. I'll try the second one. And that's 12 sine 30 divided by sine 80. 6.1. That's okay. Okay, that one's fine. Let's try this one. Sine inverse 10 by sine of 100 divided by 16. That one's worked, 38 degrees. All right, so this one hasn't worked. I can tell you probably why it hasn't worked. It's probably generating a number greater than 1. So, for example, if I put the 6 there and the 4 there, that would be grand. Okay, and when you can't get the sign of a number greater than 1, so that's what's probably happening. I can see that now. Probably should have thought about that when I was doing it. If I put the 4 there, so really what you're looking for. So that's it's probably a nice little thinking, because I'm pulling these out of my head, but that's a nice one to kind of think about anyway, is the fact that you're not going to get an answer there. Okay, if I put the 4, if that had been 6 and that had been 4, just to show you, you will get an answer. Sine inverse fraction 4 sine 50 over 6. Must be something to do with sine 50, I swear to God. There you go. 31. So yeah, it's just to do with the fact that if the numerator is greater than the denominator when you're doing the sign, you're not going to get an answer. So that's my bad on that. I'm really just pulling these out of my head just for examples. Okay, so listen, we'll try another few. These ones we do some area ones just for the fun of it. Okay. Find the area of that one. Okay, I hope you can see that. And we do one more. Okay. area of this one is 26 centimeters. That's just 7, 8, and A. Okay, so I want the area of that. I want you to find the angle A. Okay, so give it your best shot. 3, 2, 1, go. And we're back. Okay, let's see, did we get these right? So this one's pretty straightforward. Half AB sine C, 0.5 by 5 by 10 by the sine of 60, 21.61. 65 centimeters squared. And this one is going to be half 7 by 8 by the sine of A is equal to 26. So divide 6, so it's getting the sine inverse. I hope I haven't done the same thing here, of 26 over 0.5 by 56. Please God, I haven't done the same thing here. I think I should be okay. Yeah, 68 degrees. Okay, so listen, that's it. Just some examples just to get you going anyway. Okay, thank you very much. Goodbye.